In this video, we shall show how to compute the adjugate matrix. For more on this topic, you need to subscribe to this channel. We know that the adjugate matrix, for example, if the adjugate of A is equal to the cofactor transpose of A. So, if, for example, A is equal to A, B, C, D, E, F, G, H, I. How do we calculate or how do we compute the adjugate matrix of A? We should note that for adjugate matrix, we compare it with the cofactors. All of these here are the cofactors. The cofactor matrix can be written as C11, C12, C13. Then C21, C22, C23, C31, C32, and C33. So let's say this is our cofactor matrix. This is our cofactor matrix. So to obtain the adjugate of matrix A, we first find the cofactors of all of these and now transpose it. We transpose it before we can be satisfied that we've gotten our adjugate. So now for the cofactors, you put this as positive, negative, positive. For the second row, negative, positive, negative. For the third row, you come here, positive, negative, positive. Now, the next thing to do is for we to compute individual cofactor matrix. Now, for C11, say C11, we have what we write here. We look at this. We say is positive. Positive determinant of C11 will be EFHI. EFHI. So it will give us EI minus FH. Now for C12, we have a negative sign here. C12. So we have negative determinant of, for this, we exclude the whole of this line and the whole of this line. So we have DFGI. DFGI, which is equal to negative, this multiplied by this, which is DI minus FG. Also, for C13 is equal to positive determinant of C13. So we ignore the whole of this, and take DE, DH, which is equal to DH minus EG. Now, to complete this, C21 is equal to, there is a negative sign here. So we say negative determinant of, now, we ignore the whole of this, For this, we ignore the whole of this and ignore the whole of this line. So we have BCHI, which is equal to negative DI minus CH. So this is for this. Also, we also have C22, which is equal to positive determinant of C22, which is E. So we ignore the whole of this, ignore the whole of this. So what we think is AC and GI. AC and GI, which is equal to AI minus C. Also, for C23, C23 is a negative sign. So we have negative determinant of C23, which is this. We ignore the whole of this, ignore the whole of this. So we have ABGH, ABGH, which is equal to negative AH minus BG. The next one we have is C31. C31. It's a positive sign, that is B. So we ignore the whole of this and ignore the whole of this. So we have BCEF. BCEF. BCEF, which is equal to BF minus CE. Also, we have C32. C32, which is equal to, there's a negative sign. So we have negative determinant of C32, which is this. So we exclude the whole of this and exclude the whole of this line. So we have ACDF. ACDF, which is equal to negative AF minus CD. And lastly, we have C33, which is equal to C33, which is I. So we ignore the whole of this and take ABDE. So we have determinant of ABDE. ABDE. So we have AE minus BD. So this is how to compute individual cofactors of a matrix. Now, the next thing to do is that when you get your answer, because this is not in numbers, if they are not in numbers, we can't put them in this form for now. So when you get those numbers, you put them here and now transpose But this is how you can obtain the cofactor of any matrix. For more on this topic, you need to subscribe to this channel. So to obtain our adjugate matrix is equal to the cofactor transpose of that matrix. So these are the cofactors. If you get your values here, you now transpose them. Once you transpose them, you get your answer. So in our subsequent videos, we will show some examples how we can also transpose a matrix. For more on this, you need to subscribe to this channel.